Welcome back to G4 Lab CS. In this video, we'll be continuing our discussion of Topic 4, Computational Thinking, Problem Solving, and Programming. In our last two videos, we covered standard algorithms. In this video, we will cover algorithm efficiency and programming concepts. Okay, so to remind you of the IBCS syllabus, so algorithm efficiency, right? So this is taken as a quote from the syllabus. Students should understand and explain the difference in efficiency between a single loop, nested loops, a loop that ends when a condition is met, or questions of similar complexity. Students should also be able to suggest changes in an algorithm that would improve efficiency. For example, using a flag to stop a search immediately when an item is found rather than continuing the search through an entire list. Examination questions will involve specific algorithms, and students will be expected to give an actual number or a range of numbers of iterations that a step will execute. Okay, so now that you know that, here are the 6 main algorithm efficiency. These are very common. And just to go through them, the first one, big O of 1. So in IBCS we have, or just programming in general, everything is in big O notation. So big O of 1 is a constant. Big O of log of n is a logarithmic. Big O of n is linear. Big O of n squared is a quadratic. Big O of n to the power of c is polynomial, where c can be any constant. And big O of c to the power of n is exponential. Okay, so there's a great analogy. For example, let's say you're making dinner for your family. Big O is the process of following a recipe, and n is the number of times you follow a recipe. So in big O of 1, which is a constant, you make one dish that everyone eats, whether they like it or not. You follow one recipe from top to bottom, then serve one recipe. In big O of n, you make an individual dishes for each person. You follow a recipe from top to bottom for each person in your family, which is sequential. The recipe times the number of people in your family. So how many people in your family will be n, right? Big O of n squared, you make individual dishes redundantly for every person. You follow all recipes for each person in your family. Recipe times the number of people squared. So big O of log of n is when you break people into groups according to what they want and make larger portions. Then you can make one dish for each group, which is recipe times request. Okay. Now that you have a basic understanding of algorithm efficiency, you can go into the algorithm efficiency rules. So this is how you're expected to find the efficiency of a given algorithm. So number 1, add important steps together. You want to drop the constants. Number 3, different inputs use different variables to represent them in big O notation. And number 4, which is important, drop non-dominant terms. So for example, if an algorithm is a nested for loop, which would be big O of n squared, and a regular for loop, big O of n, it's not big O of n plus n squared, because the big O of n is going to be completely dominated by the big O of n squared. So it's not meaningful. So the efficiency of the whole program will just be big O of n squared. Okay, now let's go through some practices. So this question, you're maintaining a customer contact detail database for a sales business, currently with 1 million records. On any given day, several hundred customers will notify a change of address for the database. Additionally, on any given day, the support staff will receive several thousand calls through the switchboard, where they will have to look up the customer data. Should your program, 1, save new changes as they occur and have the support desk app sequentially search through the records, or bubble sort after every save and have the support desk app binary search through the records? So which one is more algorithmically more efficient? Which one is more efficient? Justify your choice with reference to the big O of n of each method. This question is 5 marks. It's a real question that might appear on your IBCS exam. So let's go through this. Option 1. So saving changes, right? That's big O of 1, right? It's constant. And searching using the sequential search, where it says sequentially search through the records, that has big O of n, because however many points in your list or how many values you have, that's how long it will take, right? Because you have to sequentially go through each step. Therefore, the over complexity is big O of n, because you drop the constant, right? As shown by the rules earlier. Option 2, however, each state requires bubble sort, which is complexity of big O of n squared, because you're dividing it in half every time, remember, in bubble sort. Searching using binary search has time complexity big O of log of n, right? And then therefore the overall complexity is dominated by big O of n squared, because that's obviously longer than big O of log of n. So the conclusion is, since big O of n squared grows faster than big O of n, option 1 will be more efficient. Okay, programming concepts. Here are some conventions and best practices that you should do when you are programming in any given language, but if you're watching this video, it's probably going to be Java. So number 1, the code layout. The code should follow tabbed indentions in blocks between braces, right? Number 2, comments. Commenting should be clear, consistent, and regular. And then the naming consistency, the name should be meaningful. Use Java conventions. And you can search these up anywhere. Variables, generally adjectives or nouns. Functions should perform one job, just one, and name it using a verb. Okay. If you want to elaborate, this information is widely available on Google. Okay. Now, this is a weird concept. Pass-by values versus pass-by reference. So, this is kind of assuming that you have some basic knowledge of memory in programming. So the transfer of information is called passing arguments or parameters. Programming languages have 2 methods of passing parameters which affect your programming's behavior. So it's pass by value or pass by reference. So first of all, pass by value, copy, right? It's a copy. The function gets a copy of your variable's value, and changes inside the function do not affect the original variable, right? Whereas in pass by reference, this is a shared location. So the function gets the same memory location as the variable. So changes inside the function do affect the original variable. If that's confusing, here's an example, right? Here we have a function that you're just squaring whatever number you put in. So this is in Java, by the way. And then you have another function that takes variable a is equal to 0, and then b is double of a, and then you want to print a and b. So the result is if you're using pass by value, then a is unchanged. So a is 10 and b is 20. But if you use pass by reference, a is modified inside the function. A is equal to 0 and a is equal to 20 and b is equal to 20. So the reason for this is when you call double it, when you call b is equal to double it a is still equal to 10. So the function gets its own variable where the number is equal to 10, and it changes its copy. It's not changing a, it's only changing its copy, right? They're separate. So inside the function, the number is still equal to 20. But a is stored somewhere else. So a is equal to 0. I mean, a is equal to 10, which is unchanged. So the final result is a equals to 10 and b equals to 20 because the function worked on a copy, not the actual value of a. So when we're doing pass by reference, right? Pass by reference is same memory. When we're doing pass by reference, it's same memory. Now the function doesn't get a copy, but it gets the same location as a. So for example, a and number is the same memory inside the program. So inside, you have number equal to number squared. This directly changes that shared memory. So a goes to 20 because you're doubling it, right? And the final result is a equals 20 and b equals 20. because both variables point to the same data. So the key detail here is one is a copy, the other one's memory. So in Java, interestingly, Java is always pass by value. And for primitive types like int, double, boolean, it behaves like a true pass by value. But for objects and arrays, the value passed is the memory address, so it acts like a pass by reference. Okay, so an example of this, Java's weird behavior, is this Java array example. So you have essentially the same program as before, as we just looked at. And you would think that Java is technically a pass by value, so it should be a copy it should be a copy instead of pointing to directly the memory. But remember, before right here, for objects and arrays, the value passed is the memory address, so it acts like a pass by reference. So this is specific to only arrays, right? So this array right here, 1, 2, 3, 4, 5, it creates an array in memory, and number stores the address location of that array. It's important to note that numbers does not store the actual data, it stores a reference to that. So what happens when you call this function? When you call this function int numbers2 equals to double it numbers, Java passes by value, but the value of numbers is equal to its memory address, so the function receives a copy of the address. So now inside the function, the data points to the same array as numbers. So here, data I is equal to data I squared. Since data and numbers point to the same array, changing data I changes the original array as well. So that is why the output, you have both of them changed and doubled, right? The key reason here is Java passing a copy of the reference, not the actual array. You don't copy the array, you copy the pointer to the array. So what if sometimes you don't want to change the original data? Because you'll have certain programs like that, right? Okay, so the solution to this, if you don't always want to do pass by reference for arrays, is you want to create a new array. This line here, this makes a completely new array in memory, and it's separate from the data, right? It's separate from data. So now when we do result I is equal to the data I squared, you're reading from data and you're storing the double value in result. So after the loop, the data will be 1, 2, 3, 4, 5, but the result is changed. It's 2, 4, 6, 8, 10 because you're squaring each value. And now when you return the new array, so now the numbers 2 is equal to the result, right? Now we're going to some of the, just hardware and conceptual things that don't require actual coding. So understanding code. Software programs are sets of instructions that are executed by the CPU. However, each one must first be translated into machine code, which are simple binary codes that activate parts in the CPU. More on that later. The CPU's functions are performing the mathematical operations like addition and subtraction. Number 2, moving data from one memory location to another, what we just did in arrays, and making decisions and jumping to a new set of instructions based on those decisions. So within that, there are two main ways that a program is converted into machine code: interpretation and compilation. A compiler translates a human-readable program directly into a machine-readable form that is executed before the program can run, whereas an interpreter translates a human-readable program into machine-readable form, instruction by instruction. The difference here is it executes each translated instruction sequentially, which turns a program is translated every time it's run. So an example of this is Python, right? Within this, there are low and high level languages. So high level languages include C++, Java, Python, Pascal, etc. It's written in a form that's very close to human language and doesn't require knowledge of hardware. And it also creates a portable program that are not tied to a specific PC or chip. So it doesn't matter whatever PC or operating system that I use. These high-level languages are very portable, right? And some of the other advantages are obviously easier, faster to write, and easier to debug. So this is what pretty much every programmer will use. And then there's low-level languages, which are a lot more rare because they're related to specific hardware of the computer, and they're closer to the native language of the computer, which is binary. So the downside of this is it's a lot harder to use and interpret. So some of this includes assembly language and machine code. Machine code is pretty much like never used anymore because of how close it is to binary, so it's very inefficient to write. Some advantages of this is you have total control over code, so you don't have to compile by the specific code programming language's syntax. There's less memory usage and faster execution. Okay, that's it for this class. So as of now, we've completed entirety of topic 4, and next class we'll be circling back to topic 1 and talking about system design. Thank you for watching.